Okay, so for this one, we're looking at skewness of data. One of the last things we're looking at. And for this example, I'm going to go back to that one on page 1 of the speeds of cars on a highway. Maybe something that we could picture. They're measuring the speeds of cars and go, okay, well, there were no cars. So where are we? Up there. There were no cars that went between 70 and 80. But if you go up by one, it looked like there were, say, 6 cars that went 80 to 90. And so we go along. There were, I read, about 15 cars that went 90 to 100, etc., etc., in our data. Now, if we look at this data, we haven't worked out exactly what the mean is, but the mean looks like it's somewhere in the middle here. And the data kind of spreads out evenly each way. It's not like there are a whole lot of people that are cruising at 150 k's an hour and hardly anyone doing 80 or 90. It spreads out nice and evenly. So you can imagine the variance and the standard distribution on this is not too great. It kind of spreads out quite evenly. So if we scroll down now to our skewed and symmetric data part of the world, and say, there's our example. Let's move myself there. And there's our histogram. So the histogram kind of goes evenly across. It's kind of normally distributed is what we say. It's, most is in the middle and then it tails off. So if we did the same but here and we looked at it in terms of a frequency polygon, it would just have that nice shape. And what we normally see in a normal distribution is this characteristic shape. So if enough people do a test, for example, then it's amazing that mostly it's going to distribute normally. It's not like 300 million people are going to get like terrible marks and like 1 or 2 are going to get great marks. Or, it's going to distribute normally is what we say. So this is the picture, and these are the pictures we want to work from. So as a kind of a quick look at it, let's put myself in the middle here and see how I do. Put me in the median or the mean. Okay, so if we've got the mean and we've got the standard, this normal distribution, then we've seen these things of the standard deviation. Now in a normal distribution, if we've got up here, if we've got our standard deviation, if we out by 1 standard deviation on each side, so in there, that means that 68% of our data is within 1 standard deviation. Quite a lot of our data is quite close to the mean. And if we go further out and we go out by 2 standard deviations, 96% of our data is that close to the mean. So much of our data is really close to the mean in a lot of ways. And then if we go out by 3 standard distributions, well, standard deviations at least, 99.7% of our data is there. So most of our data is sitting close and kind of tails off. And then there are hardly any that are way, way out. So let's see some other pictures. What happens if instead of being in this case, so let's look over there. So up here, let's use our cars as an example. In this case, most people were doing whatever it was, 110 Ks. And then as you went faster and slower, it kind of tailed off each way. Now what happens if we were to take that, and let's see how I can move myself, and should I be there? So let's say I'm going to take that data and I'm going to pull it to the right. So I'm going to pull a whole lot of these people. I'm going to say you need to go faster on the road. So I'm going to pull you and make you really right, move you to the right to move you faster. Then I'm going to end up with this scenario where they're the people that are doing 110, but look, there are way more people doing kind of 120, 130, 140, 150 k's an hour. Crazy, but they're going fast on the road. It's been skewed to the right. We've pulled that, so we've taken that bit there, and we've pulled it along to the right, and we get this scenario here. So we say that's skewed right. Let's look at the same example while we're on the skewed right. in different pictures. So if we've got a box and whisker, here it is here. Let's get it in place here. I'm going to say, you know what? I'm going to take these people, I'm going to say you must drive faster. So I'm going to pull you to the right. So this bit here, I'm going to say, you fast people, go even faster. So I'm going to pull you to the right. We're going to get this situation here. Look, there are a whole lot more people here to the right, and then a whole lot of people here. Remember, 25% is in each of these sections. So we've skewed it to the right. There are lots more fast people. Now, if we look at this in terms of our normal distribution, again, we've taken this and we've said, let's pull you to the right. So we got a whole lot more people that are going faster. So we've pulled you to the right. And look at this tail over here. These people have been pulled to the right. So there they are here. They've been pulled to be driving faster. And finally, in terms of our ogive or cumulative frequency graph, let's take our graph here and now just skew it right. Remember that on this axis is our speeds, or would have been like our marks when we were doing that. So we're going to say, let's take everyone and let's pull you to all go a bit faster. So you're going to get faster a whole lot quicker. So we're going to pull you along, so it's going to be skewed right. Because here, if we look at this, my days of being a weather person are still a little way off. We're going to get more of this type of shape. And conversely, we could do the opposite. And we could talk about things being skewed left. So if we took this one here and we said, let's pull you fast people and let's make you go slower. So we're going to pull you to the left. Then we get something more like up here. We've got more people going slowly and there are few people going fast. We've kind of, which way around? We need to go. We need to go here and pull you to the left. And that's what we're going to do in each case to skew the data left. We're going to take this and we're going to pull it to the left. So that's skewed left. A lot more people are going slower than the mean here. Okay, and so it goes for each of these and each of these. Right, so the last piece of the puzzle. Let's see how we're looking. If we've got data that's skewed one way or the other, let's start with skewed to the right. So in our example of people driving, this means that we've got a whole lot more people driving faster. So skewed right. So I'm going to cover up this part and I'm just going to, maybe I can even make myself a bit bigger here and say, here we go. Where's our example? So if we look over here, let's even move in a little bit here. We've pulled our data to the right, right? We've taken it and we've pulled it to the right. So it's skewed right. Means that we've got the mean, that's what we've pulled to the right. So we've pulled our mean to the right to go, come on, let's make it run a bit faster. Our mean is here, and our median, the middle point, must always be to the left. So the middle point of our data, the median, is always to the left of the mean. So we've pulled everyone to be faster, and we've got a whole lot more people that are going on kind of the faster side of driving faster, but the middle point is to the left. And the mode is generally over here to the left even more. Generally, we can't say for certainty, but generally it's going to be like that. Now, if we had everyone driving at similar speeds, so here we looked here and we went, okay, cool, so here we are. Then the mean, the median, and the mode all line up. And that's easy. That's when it's distributed normally. And finally, our last bit is if we had this negatively skewed. So I took that and we said, let's make everyone drive slower. Come on. So let's have more people on the slow end of the graph. So we're going to pull that to the left. It's going to be negatively skewed or skewed left because we've pulled it to the left. So we've pulled our mean to the left. So the median, the person driving, in the middle speed is sitting to the right, but our mean, that you call average, our mean is to the left. So therefore, if the mean is less than the median, then right, there we go. If the mean is less than the median, then the mean minus the median is negative. So just in numbers, can you imagine our mean was 7 and our median was 8? Well then, if 7 is less than 8, then 7 minus 8 is negative. How's that? I think it's time that you need to try a few of these. But that's kind of our explanation for now. Just kind of pulling it to one side or the other. Interesting.